So I'm going to talk about results and developments we have with two projects that relate to searching for ET and extraterrestrial probes. Our goal is to search for a specific identifiable signature from an ET probe or non-human object, or UFO, or whatever you want to call it, and which means that we are narrowing it down quite a lot to a specific hypothesis. Our search range is going to be up to 150 million kilometers from the Earth. And again, this instant validation and instant spectra and instant localization is going to be the most important bit. And in this way, we will get spatial resolution. So I'm leading a project called the Vanishing and Appearing Sources During a Century of Observation project, where I wanted to find a star that vanishes. Imagine a star that is there in multiple images, and you see it, and you really know it's there. And then one day it vanishes. That would be a beautiful technosignature of some completely new physics. And since 2016, I worked with my team of about 40 people with machine learning scientists and astronomers, and we searched for these stars by comparing images from the 1950s to images to today. We were using photographic plates that were done in 1950, in the early 1950s. For those of you who know how these photographic plates works, they're usually quite big. They serve a big part of the sky, and there were very fine studies done at Mount Palomar, for example, in Lick Observatory, the Vatican. And one great advantage of these plates is that there were no satellites. We humans had not yet contaminated the sky, and airplanes are so easy to distinguish because you just get a streak. So they are excellent for searching for ET, but you go back in time. It's like a time machine to when your sky was before Elon Musk and similars. So we were actually searching for these vanishing stars by comparing these images from the 50s and with the images from like more or less today. And we analyzed terabytes of image data automatically and through a citizen science project that unfortunately I cannot show the animation of because I have some technical issues here. But it was really a big work where we looked through many objects like one by one. And we found many short flashes that appear on one image and they don't appear again. They were appearing very shortly, briefly on these photographic plates and then just vanish. Something that vanishes at timescales less than 50 minutes. So that was quite interesting, but not as interesting as when we found 9 of them in a small region of the space that appear and vanish within 50 minutes. Because then we say as astronomers, oh, what on earth is that? The paper caused a lot of astronomers getting stressed over social media, saying that they should not be citing the paper because of some sociological issues. Actually, the same people who usually are going for AVI also went for me. Astronomers are bored sometimes. And what happened here is that we see these images. You see the green circles. You have ignored the purple circles that are scanning defects that we could distinguish by comparing different scans. But what you see is that on the 12th of April, you have 9 stars that are there in one image, or transients, as I'm going to say, for these short flashes. They are there in one image, and they are not there later. And they were not there half an hour earlier, they were not there 6 days later, and they never appeared again. So what are the implications? Well, what I try to convey is that there is some very unexplainable flashes that come in multiples in the old photographic plates that shouldn't be there. And these are in plates taken before 1957. A possibility is that we see something artificial. There is something very funny about the date that I didn't know about when we found the triple transients. Another of my friends, actually, my media agent, pointed out, you know, that date rings a bell. So then I went back and I decided to take a look at the other candidates, these aligned ones, at the top candidates that we had, because we had 5 candidates listed. And we have still a problem that, again, it coincides very close to these Washington events. And I'm going to say, it's just a coincidence, probably. So that is why we now are trying to figure out how can we test these multiple transients and actually find out if these were coincidences or if this is a real phenomenon, because I think it is a real phenomenon. We started the project on the 1st of August, so it's a very new, and it's thanks to the support of a funder. It have a balance between the field of view, the depth you search for, because you cannot use, let's say, mobile phones have a very big field of view, but they don't have very much of a depth. So all that has to work. We have selected that. Next, in order to verify and localize a probe, you need at least 2 telescopes, and the more telescopes you have, the more accurate you will have the location. And you can detect this flash in multiple synchronized telescopes, and that's what we want. And as they have a specific set distance that we have carefully selected, you will be able to measure the parallax and say how far the object is from us. The third thing we do in order to make our life easier is that we skip everything inside the atmosphere. Off with the pigeons, off with the ducks and airplanes. We don't want to do anything of that, so we stayed outside the atmosphere. And not only that, we try to, in the initial phases, we are going to try to stay even outside the orbits where you have most of the human satellites. So we are actually probing the inner solar system. We also have a very efficient method to filter away all human satellites and space debris in one go as we observe. And of course, the most important, if the ET probe detection is successful, let's activate the space garbage collectors. I would hope to find some company that would like to help us to bring down the probe. And I wouldn't worry too much about if the probes agrees with me or not. So, and I think it will be a possibility to do so. I developed this program together with Dr. Marcy, as I mentioned, who discovered the first 70 out of 100 exoplanets and also received the Shaw Prize that he shared with the Nobel Prize winner Michel Mayor for his great discoveries. He's also the creator of the Breakthrough Listen program. And the Vasco team that have been working with me on researches for transients and vanishing stars, as I mentioned, is a team of 40 people with diverse backgrounds, and we enjoy this work together. Here I had a very nice animation that I'm afraid I cannot show here. Somehow it doesn't work, but where you would be able to see how a flash here, how something is flashing, and as the globe is moving, different telescopes are seeing everything and are detecting this flash.